So, have you ever noticed that when you're under a lot of stress that sometimes you also get sick? I first noticed this my freshman year of college, which was right after my first final exams week. I had a lot of really fun plans for winter break, but I spent a lot of it on the couch because I got sick. I originally thought that this was because of poor eating habits and the lack of sleep that comes with studying for finals, but it was really how my body responded to the stress of these finals that led me vulnerable to being sick. So I know we've all experienced stress, but let's first talk about what stress is. Stress, simply put, is really our body's response to a threat to normalcy. So any change in the status quo from our daily lives can activate a stress response. This threat can be real, such as encountering a bear, or it can be perceived, such as my final exams. Clearly, the final exams weren't going to physically harm me, but my body really didn't know the difference. So this threat, be it real or perceived, can activate two evolutionary conserved systems in our body, and they both begin in the brain. Both of these systems are activated simultaneously. However, the first one that we notice is the sympathetic nervous system. The sympathetic nervous system activation leads to the release of catecholamine hormones such as norepinephrine and epinephrine. And you may know epinephrine's other name, which is adrenaline. These hormones are responsible for what is called the fight or flight response. Essentially what this response is, it prepares us to confront our stressor, either by running away or physically confronting it head on. Interestingly enough, however, catecholamine hormones don't only act on our human body, but it can also act on bacterial cells as well. Norepinephrine in particular, if you give norepinephrine to bacteria, it will cause an increase in bacterial growth. And it can also make bacteria more virulent, which essentially means the bacteria are better able to cause disease. Now, the other system that's activated is the hypothalamic pituitary adrenal axis, or the HPA axis. The activation of the HPA axis leads to the release of a family of steroid hormones known as glucocorticoids. These glucocorticoids are released in order to help provide energy for the body. However, glucocorticoids can also act on cells of the immune system. So cells of the immune system are in place in order to help fight off infections. However, glucocorticoids can kill cells of the immune system, which could potentially leave us in an immunosuppressed state, which can allow us to be more likely to get an infection. So couple the immunosuppressed state from glucocorticoids in conjunction with norepinephrine, which can cause bacteria to grow better as well as become more virulent, it kind of creates a perfect storm in our body that leads us likely to get sick. So the activation of the stress response can actually affect all systems of the body. But one system that's particularly sensitive to stress is the gastrointestinal tract. And I'll give you an example of just how severe the effects of stress on the gastrointestinal tract can be. There was a woman that was taking care of her grandchildren as well as her ailing father, which taking care of a chronically ill loved one can be very stressful. She was having abdominal pain, which was later discovered to be Crohn's disease, which is an inflammatory bowel disease that's highly susceptible to stress. Her father passed away, which is another life stressor, and the pain became unbearable. She ended up in the hospital for over a month, and she had to have a large section of her intestine removed because her disease had progressed so severely. This actually happened to my grandmother back in the 80s. I didn't know this story really until recently. About 5 years ago, she was asking me what kind of research I was doing, and I told her how I was interested in how stress can affect health. And she shared her story with me, and this is one reason why I'm so interested in how stress can affect gastrointestinal disease. However, the laboratory that I'm in is, we do not study the effects of stress on humans. We study the effects of stress on mice. So in order to study the effects of stress on gastrointestinal disease in mice, we do two things to the mouse. The first thing we do is we infect them with a gastrointestinal pathogen called Citrobacter rodentium. Citrobacter rodentium is similar to the human pathogenic E. coli. So it causes diarrheal disease. For the most part, for most individuals, it's nothing more of a nuisance. However, it can be life-threatening for some individuals. The second thing that we do to the mouse is we stress the mouse. And you may be wondering, how do you stress a mouse? It's actually pretty simple. Really easy things such as just opening the cage that the mice live in, or even picking the mouse up, is enough to invoke a stress response. So we infect the mice with the Citrobacter rodentium, and we stress them every day for about a week. And then we track the infection over time, and we look at different genes that are involved in pathology, and we also look at the pathology in the colon as well. So the first thing that we look at, is the infection, the course of the infection over a 24-day period, which is generally the normal course of a Citrobacter infection. So if you look at the y-axis, think of this axis as similar to the Richter scale that you use to measure earthquakes. So moving from a 4 to a 5 is not an increase of 1, it's actually an increase of 10. And moving from a 4 to a 6 is an increase of 10 times 10, or an increase of 100, and so forth. So what you're seeing here is the normal progression of disease in a control mouse, so a mouse we just left alone. Compare that to what we do from a stressed mouse. So notice on day 1 of the infection that there is a 100-fold increase in Citrobacter in the colons of our stressed mice compared to the controls. And by day 6 of the infection, which is just above the blue arrow, there's a 1,000-fold increase of Citrobacter in the colons of our stressed mice. Keep in mind, the only thing that we did to these mice different than the controls is we just stressed them. So the next thing that we look at is INOS gene expression. INOS stands for Inducible Nitric Oxide Synthase. It's a gene that's involved or an enzyme that's involved in producing nitric oxide, which is toxic to bacterial cells. However, if you produce too much nitric oxide, it can be toxic to human or to regular host tissue as well. INOS is necessary for the clearance of Citrobacter. You can notice on day 3 of the infection that there is a 50-fold increase in INOS gene expression in our stressed mice compared to the controls. And by day 12 of the infection, there is over a 100-fold increase in INOS gene expression in our stressed mice compared to controls. So you may be thinking, well, in the last slide, you just showed me that there's between 100 and 1,000 times more bacterial, more Citrobacter in the colons of our stressed mice. So of course, you're going to need more INOS or more nitric oxide in order to kill that bacteria. But really what happens is a lot less ideal for the mouse. So I'll show you a few pathology images. And don't worry if you're not a pathologist, because I'm not one either, but you'll definitely notice a difference. So this first image is from a control mouse. This was taken on day 12 of the infection. Generally, this is the peak of pathology. I guess you will have to take my word for it that this is a pretty normal-looking colon. I will draw your attention, however, to these circular and oval structures. These are epithelial cells that line the colon. These cells are very important because they keep the contents of the colon inside the colon so they don't move into the rest of the body. Also note the cells underneath these epithelial cells. These are the immune cells. There are a large number of immune cells that normally reside within the colon. However, during an infection, you recruit new immune cells to the site in order to help fight off that infection. So contrast this image with an image from a stressed mouse. This image was taken on day 12 also of the infection, and it's at the same magnification as the control image. Notice this area in the middle. You may notice that there are no oval or circular structures in this area, and that is because the epithelial cells in this area have been destroyed. Essentially what you're looking at right here is the hole in the colon. And so that means any contents from the inside of the colon can potentially move through the colon and other sites of the body, which is exactly what we see within these mice. We can find Citrobacter, which is normally supposed to be confined within the colon. We can find it in other areas such as the spleen and the liver. Also notice in this area, there are a lot of these purple stained cells, which are the immune cells. So there's an overabundance of recruitment of these immune cells to the site or to the colon, which, yes, there is more Citrobacter in this area. However, as you can see, it's not really all that advantageous for the mouse. So what does this mean? I think it means don't get stressed, and definitely don't get stressed when you're sick. However, I don't think that that's really possible because we can't plan when we get stressed or when we get sick. But the thing about stress is it's really on how you perceive it and how you are able to manage your stress is how it affects you. So there's a lot of different coping strategies or stress management techniques that you can use. I wish I could tell you how to completely get rid of stress. However, I don't think that's possible. You can meditate, or there's also exercise is a good way to manage stress. It doesn't have to be anything too severe. Just walking around the block is something that's very good to help manage stress. It's really whatever it is that works for you. Another strategy I'd like to mention, however, is social support. So time and time again, investigators have shown that individuals with a good social support system are less likely to get sick during stressful life events, and they also have better immune function during their stressful life events as well. Social support is important. However, being able to accept that social support is also something that is very important, which I learned the hard way a few years ago when I experienced a really big life stressor, which was the birth of my son. My son was born 4 months before I defended my dissertation at the end of my graduate career, or graduate school, which was very stressful. He's great. But I had a great social support system. I had friends, family, and coworkers that were all wanting to come over and help out with the baby, but I kept saying no. It took something really, really strange, actually. It was a bad windstorm at our house, so it knocked out power for over a day, so I couldn't even turn on a light or cook or anything. And I finally accepted the support of my friends and family, and it was like a weight was lifted from my shoulders, and it was pretty amazing. So now I offer support, especially those I know having a baby, just because I know how difficult it can be. And it doesn't take a lot of effort on my part to help out my friends and family. So if you take anything away from today, it's that stress can seriously affect your health if you let it. However, if you have good stress management techniques and you have a social support system and you can accept that support, then hopefully we can all live a better, less stressful, and healthier life.